Dear student, today in this video lecture, I will discuss about network layer design issue. So, in the first slide, we explain the main function of the network layer of the SI module. Suppose that this particular system csi.ndhu.edu.tw want to communicate with cs.berkeley.edu. So several number of routers and several number of region or network are associated with the between these networks. So network layer. So first we find several paths exist from this node to this node. Network layer identify the optimum route, any routing path selection, and different network translation. Network layer also optimize and control the congestion control, network accounting. So this type of function of the network layer. So first we summarize the network layer design issue. That network layer design issue is shown in the OSI model. First layer is the physical, second layer is data link layer, third layer is network layer, and fourth is transport. So network layer, internal subnet protocol like network, data link, and physical. These contain the router. So network layer host router protocol, data link layer host router protocol, and physical layer host router protocol. Three layers are combined. And these network service provided to transport layer. So network layers service provided to transport layer. So network layer services have been designed with the following goal in our mind. First goal of the network layer, the service should be independent of the subnet technology. First goal. And second, the transport layer should be shielded from the number, type, and topology of the subnet present. Network address made available to transport layer should be uniform numbering, plan even across LAN and WAN. Second, the service provided to transport layer, two components. First, connectionless service. Internet community based on nearly 30-year actual experience with a real working computer network, and connection-oriented service telephone companies based on 100 years of successful experience with the worldwide telephone system. The argument between connection-oriented and connectionless services really has to do with where to put the complexity, the subnet or the host. Next, service provided to transport layers support the connectionless service. Say, user computing power has become cheap, so there is no reason not put the complexity in the host. Second, the subnet is major international investment that will last for decades, so it should not be altered up with features that may become obsolete quickly. And some applications such as digitalized voice and real-time data collection may regard speedy delivery as much important than accuracy. For example, the internet TCP/IP protocol. Now, service provided to the transport layer next support the connection-oriented service. Say, most users are not interested in running complex transport layer protocol in their machines. So some service such as real-time audio and video are much easier to provide it on top of connection-oriented network layer. For example, asynchronous transmission mode networks. And internet organized also network layer, just like that virtual circuit and datagram. It's also explained in the packet servicing of the first layer. So virtual circuit in an analogy with the physical circuit set up the telephone system, and datagram in analogy with the telegrams. So some issues are solved with the help of datagram subnet and virtual subnet, like that. Circuit setup, datagram subnet are not required, while virtual circuit subnet required. Addressing. Each packet contains full source and destination address, while in virtual circuit approach, each packet contains a short virtual circuit number. State information. Datagrams on subnet does not hold state information, while each VC requires subnet table space. Routing. Each packet is routed independently, while the virtual circuit approach, route chosen with virtual circuit is set up, all packets follow the route. And next issue, effect of router failure, non-accept for packet loss during the crash. So VC subnet all virtual circuit approach in VCs that pass through the failed router are terminated. Congestion control in datagram subnet difficult, while in virtual circuit easy to enough buffer can be allocated and once of each VC. So network layer design issue. Next, internal organization of network layer. Upper layer type of subnet is like that datagram and virtual circuit. So connection less service. Use the datagram UDP over IP. In virtual circuit, UDP over IP over ATM. While connection oriented, in datagram approach, use TCP over IP, and virtual circuit ATM AL1 over ATM. So determine the routes. First routing algorithm function determining the route and maintain the route table. And desired properties for routing algorithm like that correctness. The routing algorithm provide the following function like the correctness, simplicity, robustness with respect to failure and changing conditions, stability of the routing decision, fairness of the resource allocation, and optimality of packet travel times. So fairness, optimality are often contradictory goals. Suppose that X A to A dash, B to B dash, C to dash, and X dash are number of nodes. These are connected with the help of single cable. That routing algorithm, what is seek the optimize? Means minimize mean packet delay is an above candidate, but so is maximize total network throughput. Furthermore, these two goals are so conflict since operating any queuing system, near capability implied a long queuing delay. And second, as a compromise, many network attempts minimize the number of hope packet must make. So because reducing the number of hoops tend to improve the delay and also reduce the amount of bandwidth of consumed, which tend to improve the throughput as well. Two is main factor, mean delay and throughput increase, minimize the number of hope packet must make. So network layer using different type of routing algorithm, that routing algorithm are divided into two categories. First, static routing algorithm, and it also known as non-adaptive routing algorithm. And second, dynamic routing algorithm, which also known as adaptive routing algorithm. So non-adaptive routing algorithm, this routing table is not changed according to network condition. Static routing, yeah, non-adaptive routing algorithm. In this routing table, the routing table is not changed according to network condition. While in adaptive routing algorithm, centralized routing, one node calculated the routing table. Isolate several type of adaptive routing table are used. Isolated routing do not exchange information with other nodes. Distributed routing node exchange information and makes routing decision by itself. So next routing algorithm means routing optimality principle are used. What is the meaning of optimality principle? The optimality principle state that router J is not a optimal path from router I, router K. Then routes from I to J and J to K also optimal. As a direct consequence of optimality principle, we can see that the set of optimal routers from all sources to a given destination from the tree routed the destination such as tree is called sync tree. So in the example, so optimality principle like that. A sync tree is for like that. Now every node are connected to each other. So optimality principle first create the spanning tree. The property of a spanning tree means no acyclic graph exists. a cyclic graph exists, no cycle exists between the vertex and each node. If B is flooded the information, each router are contain the information. So a sync tree does not contain any loops. So each packet will be delivered with finite and bounded number of loops. In practice, life is not quite this easy. Link, the routers can go down and come back during the operation. So different router may have different idea about the current approach. Also, we have quickly finds the issue of whether each router has a individually acquired the information on which to base the sync tree computation, or whether this information is collected by some other means. So first routing is static routing algorithm explained like shortest path from A to D. This routing algorithm is also known as Discosta algorithm. Discosta algorithm discussed in algorithm part in 5th semester. Now here described. Now, if you want, we travel A to D. Suppose several number of router are existing in the graph. Router A is source and router D is destination. So packet flooded in both adjacent mode like that A to B and A to G. Now calculate the value. B is the distance travel a path between A to B 2, A and distance between path A to G 6, A. After traveling this, we select the shortest distance of route node router. So compare router B and G. Distance is smaller B with respect to G. So next packet is flooded by router B. Router B adjacent node E and C, then packet are travel, and all node are except the source node, all node are assigned the infinite value. Now B to C, the distance is 7, and B to E distance is 2. So travel node B to A, total distance travel 2 plus 7 equal to 9B, and travel B to this point 2 plus 2 equal to 4B. After traveling this, now find the minimum node distance 9B, and those nodes are covered. We create the color dark. Now next node distance 4, 9 and 6. Now we select from router E. The packet is flooded from router E. Only one adjacent node, two adjacent node, E to F and E to G. So next E to F, the value 4 plus 2 equal to 6, and value this 4 plus 1 equal to 5. So after traveling this, find the value of G node is updated G5, E, because and this node is 6, E. Now this node is optimized from this path. So we select this path and remove the next 6, Now find out the smallest distance node G. Now G is flooded the packet of the router and find out the value of G to H equal to 10. So explain here the value of this node H8F. Next, value of this 9G. Next, we find out the value of F is the smallest. Included the path F to C and F to H. The value of F to C and value of FG. Now after calculating that, smallest value of H8F. Now next, travel from H8F H8F to D is the smallest, and we travel 8 to destination D. This is the process of shortest path algorithm of this Castra algorithm. Now, similarly, routing algorithm, other routing algorithm of use flooding. The flooding means each packet flooded the packet, and after receiving the packet, each router flooded the copy of packet. So transmit a copy each packet it received on every one of its transmission links. So advantage: robust, simple broadcasting discovery. Disadvantage: used too much resources in the flooding, because in the flooding algorithm, each receiving in each receiving of packet, each router flooded the packet except the receiving of packet from the router. So main disadvantage of the flooding algorithm: used too much resources. So how to curb the flooding? Hop count and time step. So a variation of flooding that is slightly more practical is selecting flooding. In this algorithm, the router do not send every incoming packet out on every line, only one those lines that are going approximately in the right direction. So this is main disadvantage of flooding algorithm. Now next lecture